Hi, I'm Lavanya, and this is my submission for the Capstone project in the CS780 OBELIX. The task pretty much sounds very simple. You have a gray box, and there is a bot which needs to push it off the boundary. But it was, as I saw, it was pretty difficult over the 4 weeks, and so there are because there is limited observability, and our agent can't differentiate between what is a wall and what is a box. So that's where the difficulty arises from. So in my first week, I started with a handcrafted finite state machine with three modes, which are charge forward, spiral turn when stuck, and escape if it's still stuck. There was no learning at all, but it performed pretty well without on difficulty level 0 and without walls. But with walls, as you would expect, it got stuck against the wall because it can't differentiate between box and a wall. So that's where the learning should start. That's where the reinforcement learning should come in. And the next week, in week 2, I went the other direction of pure tabular Q learning with 2 raised to power 18 states. On the easiest setting, it actually beat everything else, but the moment I added blinking or movement, it collapsed. Totally, which is totally different, which are totally different situation which look identical on the table. So that told me I should give temporal context to the bot, and instead of raw 18-bit states. So I engineered 4 features and stacked them across 4 time steps. So that's like total 88 dimensional state space representation for all my algorithms thereafter. So this agent which you are looking on the screen is a PPO agent, and with reward shaping involved, because as I saw while training my D3QNPAR model, my agent just ended up spinning at place to avoid any negative rewards. But our task in hand is to just attach to the box and push it off the wall, which the bot just did. So it's pretty much spinning in the same point, but there are some forward movements, and as soon as the agent sees the box, it just pushes it off the boundary, which is the correct behavior, I guess. So like in hindsight, I should have, if I had more time to train my PPO agent, I would have done it over over a curriculum of different difficulties to like it teach the agent to move forward more often, and how to detect walls and just go through them without like getting stuck on walls. So to summarize, the single most impactful thing across all 4 approaches was giving the agent just temporal context and the reward shaping as well. So not the algorithm actually, and not the architecture, just to making sure it had enough information to tell what was happening. The code and the weights and the full report are all on my GitHub. And thanks for watching.